Hey everybody, it's Wilman here. I'm just going to do a quick video to kind of go over what our next unit is going to be. And we're going to run through some practice examples together, so hopefully you guys will be set up for success on the independent practice. So here we go. So we just finished our unit on solving equations. So kind of going along with equations, we're going to have something called inequalities. And we've talked about them earlier in the year. So for starters, let's kind of talk about a definition. An inequality compares two values, basically using the following signs, okay? Remember, less than, greater than, and then we got less than or equal to, along with greater than or equal to. So all we're doing is comparing two things, two numbers, or two values, and we're basically just deciding whether or not they're less than each other, greater than each other, less than or equal to, or greater than or equal to. So these would not be a bad thing to take a note of in a notebook or on a separate sheet of paper, totally up to you, because this is basically where we're going to go. So we're going to start off pretty simple today. Let's say I had something like this, question 1. X less than 5. Okay. This is going to look a little strange because the only work we've had with inequalities so far is stuff like I'm going to write in red. 3 less than 7. 4 greater than or equal to 4. All we've done in the past is compared two numbers and said if it is true or if it is false. Is 3 less than 7? Yes. Is 4 greater than or equal to 4? Yes. But notice what I have written in black, x is less than 5. There is one number and one variable. I have the variable x here instead of another number. So we're going to look at it a little differently. Let's think about it for a second. X is essentially in the spot of a number. What are all of the different numbers that are less than 5? Well, there's 4, there's 3, there's 2, there's 1, there's 0, there's -1, -2, -3, -119, -287. There's a lot of numbers less than 5. So I just can't say 4 is less than 5. I need to somehow list all possibilities. And basically how you're going to do that is by drawing one of these. A number line, kind of like I have here in that darker font. So here's what I would do. Put the number that you're given in the middle. So I'm given a 5, okay? What numbers would come to the right of it? Remember, on a number line, larger numbers always come to the right. So there would be a 6 here, a 7, an 8, a 9. So that would mean to the left it would be 4, 3, 2. Okay. If I'm looking for numbers less than 5, I'm talking about this number, I'm talking about these numbers, I'm talking about all these numbers up to the 5, okay? Think about this. What I'm about to write in red. Is this true? Is 5 less than 5? Meaning, is 5 smaller than 5? No. 5 is not smaller than 5. They're equal to each other. So my little yellow line I drew cannot include 5. The way we show not including something would be with an open dot. So I would write not including means open dot. And what I mean by an open dot is this. Put an open dot on 5, just a circle around 5, meaning we're going to start at 5 and look at every number smaller than 5. So every number smaller than 5. So right here, right here, right here. But think about it. How many numbers are actually smaller than 5? It turns out there is an infinite number of numbers that are smaller than 5. You can't count them all because there's always one more. So instead of just drawing this little yellow line, I'm going to put an arrow on the end. That tells me that if I keep going smaller than all of those numbers, any of those numbers are smaller than 5. Okay? So I would say step 1, put the number you're given in the middle. So I put a 5 here. Then what you should do is decide if it's an open dot or a closed dot, okay? And then finally, you just draw your arrow shading those values. So let's do a couple more together so we kind of get the hang of it. Let's say I want to know this. Let's say that y is bigger than or equal to negative, or no, let's do 7. Y is greater than or equal to 7, okay? What numbers are greater than or equal to 7? Okay. I know it's just not one number because it's an inequality. There's lots of possible answers. So I'm going to put a 7 in the middle on my number line. So that means to the right of it, I'm going to have things like 8, 9, 10. And to the left, I'm going to have 6, 5, 4, and so on, okay? I want to know which of these numbers on here are bigger than 7. Well, bigger than 7 would mean 10, 9, 8, everything up to there, okay? Think about this. Is 7 actually greater than or equal to 7? Is that true? Yes, that's true. If you see that greater than bar underneath your less than or greater than, that means these two numbers can be the same. So is 7 greater than or equal to 7? Yes. So what does that mean in terms of my number line? That means I want to include 7. So instead of just drawing an open dot like I did in that first example, I'm going to do a closed dot. That means I want to include the number. I want to include that 7 in my answer. So I'm going to draw a circle and then color it in, okay? That means any number 7 or bigger is right there. But again, I just don't want to have my line go up to 10. I want to draw an arrow to show that it goes on forever and ever, because there is an infinite number of numbers bigger than 7. There's 11, 12, 13, 14, 1,000, 10,000, 20,000, okay? So I'm going to put 2 on the screen. You guys can pause the video, try them on your own, or you can just wait patiently and we can do them together. All right, so let's do P is greater than, let's do -3. And negative x is less than or equal to 2. Okay, so starting over here, P is greater than -3. What numbers are greater than -3? Let's find out. So if I put -3 in the middle, what numbers are going to be to the right of it? Well, they've got to be numbers bigger than -3. So it'd be a -2, -1, 0. Or another way you can think about it, numbers to the right mean closer to 0. And numbers to the left mean farther or further from 0. Okay? Right versus left. So that means to the left, farther from 0, I'm going to have -4, -5, -6. Okay? I want numbers bigger than -3. So I want numbers to the right. Numbers larger than -3. So -2, -1, 0, all these guys right here. But those aren't the only ones I want to include. I want to include past 0. So I'm going to draw my arrow. Final question. -3. Should I put an open dot or a closed dot on -3? Well, put a -3 in for your P. Is -3 greater than -3? No, that is not true. They are equal. They are not, one is not greater than the other. So I'm going to have an open dot. I am not going to include -3, but -2.99999 will work. As long as it's not -3, it will work, okay? And I know you're probably thinking this, Mr. Willman, how do I know if my answer is right? Well, this is what you should do. Check by picking an answer in your shaded area. So pick any number over here that you see. So I'm going to say, pick -1. Put that into your original inequality. Check to see if -1 is greater than -3. Is -1 greater than -3? Or is -1 closer to 0 than -3? Yes, that is true. So we know that what we drew down here is correct. Open dot at -3, shaded to the right. Okay? All right, one final example that you're going to notice over here. -x is less than or equal to 2. Okay? So let's pretend I would do it my normal way. Let's say Mr. Willman would draw a line at 2, 3, 4, 5, 1, 0, -1, okay? So I would do this, less than 2, so I'm going to draw over here, less than 2, so like 1, 0, -1. I see less than or equal to, so I'm going to do a closed dot, and I got my arrow. Mr. Willman, that's the right answer. Okay, well, let's check it. If I would put a 0 into this inequality, you would get -0 is less than 2. Less than or equal to 2. Okay, I get that. That makes sense. Let's try this one. What would happen if I would put in a 1? -1 is less than 2. Mr. Willman, that still works. Okay, I get you. But think about it. What numbers are over here? There's a -2, -3, -4. I'm going to try a -4. So -4 would be a +4. Okay, if I put in a -4 right here, a negative times negative is positive. So I'm essentially getting 4 is less than or equal to 2. Is that true? No, that is not true. 4 is not less than or equal to 2. There's a mistake somewhere. What do you notice about the first 3 examples we did compared to this last one? What you should notice is all of the variables are positive. Positive x, positive y, positive p. But in our last example, I gave you a -x. If you have a negative next to your variable, you need to get rid of it. You need to think for a second, what number is in between the negative and the x, even though we don't write it? There's a 1 right here. How do you get rid of that -1? What's the opposite of multiplying by a -1? Dividing by -1, okay? If you divide this side by -1, you are going to be left with 1x. What happens if you take 2 divided by -1? Well, you're going to get -2. And since we divided by a negative, our original inequality sign is going to flip directions. So it's going to be like this. x is greater than or equal to -2. That is what we actually need to use to answer or to graph our inequality, okay? So let's graph that instead and check our answer. Okay, so I'm going to put a -2 in the middle, and then to the right I'm going to do -1, 0, -3, -4, okay? I want to include -2 because I have this symbol, greater than or equal to. Include -2, greater than or equal to -2. So I actually want to go to the right. Notice, if we would have done it the original way we started, we shaded to the left. We actually need to shade to the right of -2. So let's check. Pick one of these numbers you see. Pick one of these numbers. Is -1 greater than or equal to -2? Yes, it's closer to 0. Is 0 greater than or equal to -2? Yes, it is. It's closer to 0. It's actually 0. So the point is, this is our last note for the video, if you multiply or divide by a negative number, flip the inequality sign. Then graph, okay? And just to kind of finish this idea, I'm going to do one more quick problem, okay? Let's say we had -y is greater than 1. Since there is a negative in front of your y, you want to get rid of that. You want to divide both sides by a -1. And what that's going to do is it's going to make your y actually positive, because a -1 divided by -1 is positive 1y. And on the right, a 1 divided by -1 is -1, okay? And you need to flip or switch this greater than symbol to a less than symbol. So you started with -y is greater than 1. We got down to y is actually less than -1. And this is how you would graph it. -1 in the middle, 0 over here, +1, -2, -3. Let's see, the symbol is less than, so I want to have an open dot. I do not want to include -1. And I want numbers smaller than -1. So smaller means to the left. So if you pick any number in the red there, it is going to be true, okay? All right, so that was our introduction video on inequalities. Remember, inequalities are basically comparing two values using less than, greater than, less than or equal to, or greater than or equal to symbols. To graph them, you need to put the number you're given in the middle. You need to decide if it's an open or closed dot, basically meaning should I include this or not. And then you need to shade either left or right to show that you can include all of those numbers there, okay? And again, that final note, if you have a negative in front of your variable, you need to multiply or divide by that negative. And when you do that, you need to switch the way that the symbol of the inequality is facing before you graph, okay? All right, that's going to wrap up our inequality unit, or our inequality video, excuse me. We have some practice problems listed on our Google site, so check those out. There's also an answer key provided. As always, let us know if you have questions. Thank you for watching.